Have you ever wondered what strange secrets our solar system holds? From bizarre storms that rage for centuries to moons with hidden oceans, our cosmic backyard is filled with mysteries that defy explanation. What if I told you some of these phenomena could reshape our understanding of the universe? Join us as we explore the top 10 strangest phenomena in our solar system, uncovering the wonders and enigmas that make our celestial neighborhood so extraordinary. Jupiter's Great Red Spot. A swirling crimson storm on Jupiter, larger than Earth, has raged for over 350 years. This massive anticyclonic storm is one of the most iconic features of our solar system. Scientists believe the red color might come from complex organic molecules formed under intense UV radiation, but no one knows for sure. The Great Red Spot's winds reach speeds of over 400 miles per hour, making it more violent than any hurricane on Earth. It's shrinking over time, leaving researchers puzzled about its ultimate fate. Could it disappear entirely or transform into something new? What's truly fascinating is how deep this storm goes. Recent data from NASA's Juno spacecraft suggests the storm extends hundreds of miles into Jupiter's atmosphere. This depth gives scientists a glimpse into the planet's mysterious weather patterns. The storm's longevity is another enigma. While storms on Earth last days or weeks, Jupiter's atmosphere lacks a solid surface, allowing storms like this to persist for centuries. But the mechanics of its formation and endurance remain elusive. Jupiter's Great Red Spot isn't just a storm. It's a window into the planet's chaotic and extreme atmospheric dynamics. Understanding it might help unravel mysteries about weather patterns on gas giants and beyond. Saturn's Hexagonal Storm. Saturn's North Pole boasts a geometric wonder, a perfectly shaped hexagonal storm system. Unlike anything seen on Earth, this six-sided jet stream spans about 20,000 miles across. Its symmetry leaves scientists scratching their heads. The hexagon structure likely forms due to fluid dynamics, where different wind speeds create a stable, standing wave. But why it takes this precise hexagonal shape instead of a circular one remains a mystery. Images from the Cassini spacecraft revealed the storm's depth and color changes over Saturn's seasons. This dynamic evolution adds another layer of complexity to its already puzzling nature. Beneath the hexagon lies a massive hurricane-like storm with an eye and spiraling arms, adding to the polar region's bizarre and chaotic weather. These layers of storms might hold clues to the gas giant's atmospheric mechanics. Saturn's hexagonal storm isn't just a strange shape, it's a planetary phenomenon that challenges our understanding of weather and fluid mechanics. It reminds us how alien the weather on other planets can truly be. Uranus's tilt. Uranus spins on its side with an axial tilt of 98 degrees. This means it essentially rolls around the sun like a barrel. No other planet in the solar system behaves this way, making Uranus a true oddball. The tilt likely resulted from a massive collision early in the planet's history. A protoplanet or giant object could have struck Uranus, knocking it over. But the details of this ancient event remain speculative. This unusual orientation creates extreme seasons. One pole experiences 42 years of sunlight, followed by 42 years of darkness. The planet's atmosphere also features high-speed winds and faint rings, all aligned with its peculiar axis. Another mystery is Uranus's magnetic field. Unlike Earth's relatively aligned magnetic and rotational axes, Uranus's magnetic field is wildly skewed, further emphasizing its chaotic nature. Uranus's tilt isn't just a quirk, it's a reminder of the violent events that shaped our solar system. Understanding its unique orientation could provide insights into planetary formation and evolution. Venus's runaway greenhouse effect. Venus, often called Earth's twin, offers a cautionary tale of a climate gone wild. With a surface temperature hot enough to melt lead, Venus's atmosphere is dominated by carbon dioxide, trapping heat in a runaway greenhouse effect. Scientists believe Venus may have once had oceans and a more Earth-like climate, but volcanic activity released massive amounts of CO2, causing temperatures to spiral out of control. Now its surface is a scorching wasteland. The thick atmosphere also leads to crushing pressure, about 92 times that of Earth. Spacecraft that have landed on Venus survive mere hours before succumbing to the heat and pressure. Adding to the mystery are Venus's clouds, which contain sulfuric acid. These clouds reflect sunlight, making Venus appear bright from Earth, yet they also obscure its surface from direct observation. Venus's extreme environment provides a stark contrast to Earth and serves as a warning of how delicate planetary climates can be. Neptune's supersonic winds. On the distant icy world of Neptune, winds rage at speeds exceeding 1,200 miles per hour, faster than the speed of sound on Earth. Despite being far from the sun and incredibly cold, Neptune's atmosphere is shockingly dynamic. These supersonic winds likely arise from the planet's internal heat. Neptune radiates more energy than it receives from the sun, fueling its turbulent weather. One of Neptune's most iconic features, the Great Dark Spot, is a massive storm similar to Jupiter's Great Red Spot. Though it's transient, appearing and disappearing over the years, it showcases the power of Neptune's atmosphere. The planet's deep blue color comes from methane in its atmosphere, which absorbs red light. But why Neptune's weather is so extreme remains unclear. Neptune challenges our assumptions about planetary weather, showing that even cold, distant worlds can harbor violent, energetic storms. Mars's dust storms. Mars experiences planet-wide dust storms that can last for months and cover the entire planet. These storms are the largest in the solar system and have even grounded rovers like Opportunity. Dust storms on Mars are driven by solar heating, which causes atmospheric pressure differences and creates strong winds. These winds lift fine dust particles into the air, creating massive swirling clouds. The thin atmosphere means these storms aren't very strong in terms of force, but they're incredibly widespread. The fine dust can block sunlight, plunging the planet into darkness and drastically affecting temperatures. The storms also play a role in shaping Mars's surface. Dust settles into dunes and patterns that reflect the planet's dynamic weather. Understanding these storms is crucial for future human missions to Mars. They highlight the challenges of living and working on a planet so different from our own. Mercury's shrinking planet. Mercury, the smallest planet in our solar system, is gradually shrinking. Evidence from NASA's Messenger spacecraft revealed that Mercury's surface is covered with massive cliffs, or lobate scarps, that formed as the planet's interior cooled and contracted. This shrinkage is caused by the planet's metallic core losing heat over billions of years. As the core contracts, the outer crust crumples, creating cliffs that can reach over a mile high and hundreds of miles long. Unlike tectonic plates on Earth, Mercury's crust is a single shell, which wrinkles as it compresses. What's fascinating is the planet's ongoing geological activity. Scientists believe Mercury is still contracting today, making it a dynamic world despite its small size and proximity to the Sun. This process also affects Mercury's magnetic field, which is weaker than Earth's. The cooling and shrinking of its core likely play a role in the mysterious offset of its magnetic field from the planet's center. Mercury's shrinking serves as a reminder that even the smallest planets are not static. Understanding this phenomenon provides insights into how rocky planets evolve and change over time. The Singing Comet, 67P. Comet, 67P/Churyumov-Gerasimenko, explored by the Rosetta spacecraft, stunned scientists when it was found to sing. The comet emits a strange rhythmic sound, an oscillating magnetic field generated by charged particles interacting with its surface. This haunting sound is far below the range of human hearing, but was amplified by scientists to reveal its eerie melody. The exact mechanism behind the singing remains unclear, adding an air of mystery to this icy traveler. Comet 67P's unique shape, resembling a rubber duck, adds to its intrigue. This odd form likely resulted from the collision and fusion of two smaller comets billions of years ago, giving it a distinctive profile, unlike anything else in the solar system. As the comet approaches the Sun, its frozen gases vaporize, creating jets of gas and dust that stream into space. These interactions might amplify the singing effect, revealing the comet's dynamic and ever-changing nature. Comet 67P is a window into the early solar system, offering clues about how planets formed. Its song is a cosmic soundtrack that reminds us how alive the universe truly is. Pluto's frozen heart. Pluto, once considered the ninth planet, boasts a striking feature, a heart-shaped glacier called Tombaugh Regio. This icy plain is made of nitrogen, carbon monoxide, and methane ice, and it defies expectations by showing signs of geological activity. Despite being billions of miles from the Sun, Pluto's heart is a dynamic region. The ice appears to flow like glaciers on Earth, reshaping the surface over time. The heat driving this movement likely comes from radioactive decay in Pluto's core. but scientists are still unraveling the exact mechanisms. Tombaugh Reggio's left lobe, Sputnik Planitia, sits in a massive impact basin. The basin's location is thought to stabilize Pluto's spin, and its reflective ice plays a role in the planet's climate by affecting how heat is distributed. New Horizons flyby also revealed strange polygonal patterns on the glacier, likely caused by convection currents beneath the surface. These patterns indicate a planet that, despite its distance and cold, remains surprisingly active. Pluto's heart symbolizes more than geological activity. It's a reminder that even the smallest, coldest worlds can hold extraordinary secrets. Enceladus's Cryovolcanoes. Saturn's moon. Enceladus hides a global ocean beneath its icy crust. Its surface is marked by dramatic cryovolcanoes that spew water vapor, ice, and organic compounds into space. These plumes, discovered by the Cassini spacecraft, are among the most exciting phenomena in the solar system. The source of these cryovolcanoes lies deep within Enceladus. Tidal forces from Saturn stretch and compress the moon, generating heat in its core. This heat melts ice into water, which escapes through cracks in the surface as geysers. Scientists are particularly intrigued by the discovery of organic molecules in these plumes. Combined with the presence of liquid water and internal heat, Enceladus is considered one of the best places to search for extraterrestrial life. The plumes even create Saturn's faint E-ring, spreading tiny ice particles into orbit around the planet. This dynamic relationship between the moon and the planet showcases the interconnected nature of celestial bodies. Enceladus's cryovolcanoes represent more than geological activity. They're a glimpse into the possibility of life beyond Earth. As one of the most captivating destinations in our solar system, this icy moon holds mysteries waiting to be explored. Our journey through the solar system's strangest phenomena shows just how diverse and mysterious our cosmic neighborhood truly is. From icy moons and singing comets to shrinking planets and hexagonal storms, these wonders remind us of the universe's endless surprises. If you enjoyed this adventure, be sure to like, share, and subscribe to InnoVision Tech. Hit the bell icon so you never miss our latest explorations. Until next time, keep exploring the cosmos with us.